The quadratic equations have three function forms. The first form that we'll talk about is called the general form. General form. And it looks like this: y equals ax squared plus bx plus c. Now, a numerical example of this would look like this. So example, let's say f of x or y equals x squared plus 6x plus 8. So in this case over here, my the a is 1, the b is 6, and the c is 8. General form doesn't help us too much, doesn't give us much information. What it does give us is the y-intercept. So this here, this last term here, c, is the y-intercept. We can use the general form to find the zeros by writing 0 equals and then recopying x squared plus 6x plus 8, and then using the quadratic equation here. Quadratic equation, let me remind you what the quadratic equation looks like. It looks like minus b plus or minus the square root of b squared minus 4 times a times c, all of which is divided by 2 times a. So this will give you your zeros, x1 and 2, where x1 and x2 are your two zeros. If the value under the square root becomes 0, and you take the square root of 0, you'll get 0. So all of this vanishes, and what you're left with is minus b divided by 2a, which is just 1 0. You'll only have 1 0. So it's possible to have just 1 0. Let me remind you how that works. If your parabola touches at its minimum point on the x-axis, then you only have 1 0. As opposed to, for example, if it crosses the x-axis at 2 points. And finally, it's also possible to have no 0 if the parabola opens upwards and is above the x-axis, or, for example, if it's below and opening downwards. So general form is used to find the y-intercept, and you can plug in a, b, and c into the quadratic equation to solve for the zeros. Another useful form is function form. Function form. And this one looks like y equals a x minus h squared plus k, where h and k will dictate how to translate your function. So h is a horizontal translation and k is a vertical translation. In fact, h and k is your vertex. So it's your starting point. Let's see. Vertex is h comma k. And finally, there's a third form. Third form is called the zeros form. And it looks like this: y equals a x minus x1 x minus x2. And in this case over here, you already know what your zeros are. They're x1 and x2. So if I have a graph and I know that x1 and x2 are my zeros, let's say that this is x1, let's say that this is x2. If a is positive, then it opens upwards and does this. If a is negative, then it would just be opening downwards, but still going through those 2 points. Basically, x1 and x2 are your zeros, and a, whether it's positive or negative, dictates whether it opens up or down. Now let me point out one thing over here. You've got a here, and a here, and I've decided to use the same parameter letter A, and A for the three forms for a specific reason. The reason that I've used A 3 times in a row is because when you convert from one form into another, the value of A is always the same in all three forms. Now in the next video, when I show you how to convert from general to function, function to zeros, or zeros to general, when I show you how to convert from one form to another, you'll see how A remains the same in all three forms, and the only thing that changes is the value of the other parameters B, C, H, K, x1, x2.